Hello, everyone. Glad to be presenting to you the post-afternoon session. I know it's a hybrid summit as well. We've been talking about hybrid models and so forth. So we come to you with our experiences learned as well as adapted as we are scaling data-heavy transactions for TransUnion products with Aerospike and Adaptive Map. Myself, Ramesh, Mohan, and Bharath, we are part of the Fraud Prevention and Risk Solutions Product Engineering Group within TransUnion. Moving forward, TransUnion's digital authentication solutions provide digital insights that help authenticate the consumer that is behind devices for various transactions, for various applications, for a variety of industries, right? We help quickly flag interactions at a high risk for digital fraud while reducing friction for our customers, right? How do we assess the risk of such anonymous users and distinguish legitimate interactions from such fraudulent possibilities, right? On one hand, you would want to drive digital adoption. On the other hand, we definitely are aware of the fraud use cases, right? So it is pertinent to bring to bear intelligent data sets that in a combination can provide precise intelligence that drives authentication, yes or no, or provide a higher level of challenge to the authenticating users. Here comes the data-heavy ecosystem, right? TransUnion's solution essentially allows to tie identity attributes, be it name, be it phone numbers, and a variety of digital attributes online as well as offline, linking them with device attributes, thereby providing precise authentication solutions. Let's move forward and see how that looks like. In this data-heavy ecosystem, we provide digital insights from our Aerospike cluster. We are fully built out on an all-flash configuration. We store billions of records containing multiple dimensions of identity and transactional data, right? On one hand, bringing flash actually provides a different level of challenge because it's a trade-off between the amount of data that can be stored as well as the response. Right? We all know that performance while using all flash could be challenged at times, but based on the various possibilities that we have tried out, working together with Aerospike architects like Andrew Chen, Piyush, Debaron, and our trusted consulting partners, Greg West and others, we were able to come to a particular solution that is able to fit our needs to cater to this data-heavy ecosystem that generates digital insights and authentication solutions, right? We do close to 4 billion records that get updated every day because our fraud prevention solutions need to be as current as possible. Right? In addition, we cater to global customers leveraging millions of API transactions that need to be low latency, as well as they need to contain necessary fraud features as well that will provide the intelligence for our customers to take the risk challenges as well as appropriate responses. Moving forward. With this, I will hand off to Bharath to explain the technical scenario and the key challenges that we set out to resolve. Bharath?
Thanks, Ramesh. Good afternoon, everyone. This is Bharath Gowda. I'm working as an architect in TransUnion. So we recently migrated our data from Kayak TV to the Aerospike. Kayak TV is one of our in-home database product. So in this journey, we encountered multiple challenges. starting from schema design till the performance tuning of the client API. So today we like to present one of the scenario which we found challenging while migrating that. So this is the use case where we had to save a time series of data points spanning from few hundreds to several million per primary key. And Aerospike had a restriction on the record size, which is equivalent to the write block size. In our case, it was 1 MB, so we had to distribute the time series across multiple records and link them together to one root node. So that was one challenge, and also we also maintain the custom ordering while distributing the data to introduce some sort of randomness to the data which is asked from the customer API. Apart from this, we have also had to serve the customer API with sub-millisecond to millisecond response time. And most of our rate transaction, it was spanned across multiple sets, varying from 2 to around 10 sets in one of the API. And we also had to maintain the recency of the data. So the incoming data keeps coming in, and we had to load those data in parallel without impacting the customer response time. Go to the next slide. So that was the challenge, and in next few slides I will go through what was our initial approach and how we evolved to mitigate those challenges using Aerospike libraries and APIs. So our initial approach was traditional read, modify, write approach using generation version, which is one of the offering from Aerospike to optimistically log a particular record to maintain data consistency. And we also had few business logic while updating any record. We had to evaluate whether to add the data or modify or replace the data. And also we had the split record splitting logic as well when it exceeds the write block size. So these were the challenges we had, and because of which we could not scale up with the first initial draft version. So like we were looking for different libraries, and as I said, one of the requirement was to scale out a record to hold unlimited number of data points. Also, we had a similar design in mind, and when we reached out to Aerospike, they shared their own library, which is adaptive map, which was doing similar thing. So it is not commercialized, so there is no support, but we took their source code, we enhanced it, customized to our requirement, and at the high level, the adaptive map works in this way, like when the record is within the 1 MB size, the root record holds all the data. If the data expands and exceeds the write block size, then the adaptive map will automatically split the records into child records, and now the root record will only hold the index, not the data. So this was helpful to scale the incoming data for a particular primary key. To give a quick example in layman terms, take that we are using a combination of city and day to capture weather information. If it is hourly, we can accommodate that particular data in one single record. But if the requirement comes where instead of hourly data, we have to save in second basis, then adaptive map can do that for us without changing any code. It can dynamically scale up, splitting the records and still maintaining the order. Yeah. Yes. So as I already said, we also had few business logic at our client end, which we need to evaluate before adding any data to the actual Aerospike record. So that was one challenge we had, and also the extra overhead of splitting the records and identifying the root, whether root record is split or not. If it is split, identifying the right child record and adding that. So this was not automatic enough. We could not scale up with this kind of transaction, not through batch or asynchronous calls. So we had a limitation here. So, so that is where the Aerospike expression came in handy. So expression is a domain-specific language which helps us manipulate the database based on certain criteria. So this allowed us to port all our end-side business logic to expression operations, which will evaluate at the server end. So this eventually avoided the transaction, like a read transaction. We don't have to read the data to the client and evaluate our business logic. So we can directly send our updates to the server, and based on the expression results, either we used to insert, modify, or replace the data there. So there was one other API in the Aerospike which is operated with it, which allows multiple bin operation to be executed in automatic way. So even that helped us to resolve most of the issues we had previously in the first approach, where we were like 20 to 30% of our transaction was failing because of generation error previously. Now those things were resolved because of atomicity here, and this increased the performance of our write operations. Since the operations became automatic, it gave a chance for us to scale further using batch or asynchronous calls. So, Ramesh, can you go to the next slide? So, we identified since we had splitting logic in the adaptive map, we cannot directly port those operations into a batch calls or asynchronous call. So we identified a few of the use cases which can be ported to the batch operations. So one operation was to directly, if the root record is not split and it has enough room, we can directly write it to the parent record. And if we know if a record is split, and if we know what is the child record for which we have to make updates, then it can be made as a batch call. Any other corner cases, like we need splitting, so that was handled differently. So our approach was batch first approach, where we optimistically thinking that the record is not split and has enough proof. So we were trying to write directly to the root node, and in any failure transactions based on the type of result code, if it is a record to big error because of overshooting the write block size, we used to process that in a separate queue, which used to be a synchronous transaction. And if it is failed because of root record is split, Then we used again a batch call to find out what was the right child record to be inserted, and use batch operation to insert the respective child records. Using this combination of both batch as well as synchronous call, we were able to scale up our application to mitigate all our challenges. Today, I think with this setup, we are able to do around more than 100 billion write and modify transaction. Uh, I think this was the overall solution. I take a pause here and Alu want to walk us through further. Thank you.
Thank you, Bharat. So I will walk you through some of the statistics with this combination of adaptive map expressions plus batch operations. With that, how far we have evolved in our solution. So yeah, of course, adaptive map. So we did not have performance penalty in our use case because with the expressions we were able to move a lot of the business logic computations in the server side. And then in expressions as well, we have applied filters, and because the server-side logic computations, we were able to save the network traffic time. And with the batch operations, we had tried to combine most of the CRUD operations possible in a batch and try to send it together to avoid network traffic. So again, for our use case, we had to load a lot of historical data to be in the place for the day one of production readiness. So we had to load a lot of months of historical data. For that, we needed an effective loading mechanism. So that is where we have applied all this. So with the help of this, we were able to load 20 to 30 days of data for cost. Yeah. So we are able to load 20 to 30 days of data in a one particular day of time. So essentially, we were loading around 60K plus transactions per second. Moving on, in terms of reading, so we had to read the data from this data structure for a couple of reasons. One is to perform updates. If we received a new data point for a same primary key, we have to perform update operation during the loading time. So that was one of the use cases to read. And then even to respond to the customer API transactions, we had to read from this data structure effectively and share the data points to take a call in terms of fraud transactions, right? So essentially, since as you know this data structure, either the data could be in the root record directly, if it is less than 1 MB, or if it is beyond that, it will get split and root record will hold the index and the actual data points will be present in the child record, right? So when it is only present in the root record for read operation, it's going to be only one DB call. So where we directly read the, for a given primary key, we read the data and then serve it. And if it is split, then it is going to be irrespective of how many splits happens, it is going to be 2 DB calls in our use case. So the first DB call fetches all the indexes of the child, and then based on the number of child and few other various parameters, we decide dynamically whether to go for a batch call to take the rest of the data content from the child records, or some of the cases we went ahead with asynchronous calls to get the child record data. And so during this exercise, even for loading and reading purpose, so many of the operations were batch. So the by default version of Aerospike Grafana was not giving much visibility. So that is when we reached out to Aerospike, and then they have provided some of the custom charts which helped us to understand the batch operations better. Say for example, latency batch index metrics, which was the one widely we had used during this loading and reading of large volume of data. So where latency batch index provides a view how the batch operations are happening. Is there any outliers happening in the batch operations, etc. So with the help of that, we were able to figure out that for our batch operations, 99% of the data we were able to batch operations were less than 90 millisecond, and for 99.9% it was less than 150 milliseconds for the batch operations, right? So even when we had a customer API transactions that were coming in peak, so even that time we were able to do the data load, and for the customer API transactions, for close to 99% of the transactions, we were able to respond within few milliseconds with the help of this approach. So so specifically on the API transactions, as Bharath highlighted, we had to read from multiple sets at a time. So that's when we had used batch and asynchronous effectively together in those scenarios as well. So moving on, we haven't stopped there. So the last few months we have been working on some of the data model improvements with the help of non-blocking batch calls and asynchronous implementation, and of course the custom adaptive map plus expressions to make the more atomic operations. And again, for the data heaviness, we had split with the help of adaptive map and expressions we had widely used to perform the CRUD operations based on certain criteria and filtering. So this all helped us to improvise in terms of the data model. And recent past month, we have started engaging with Aerospike team on client instrumentation, where some of the odd API transactions we are trying to figure out with the help of Aerospike client instrumentation tool, why certain transactions are taking more time, where is the gap, either it is in the network or is it in the data side or the DPI operations. So it gives a lot of detailed logs, the instrumentation tool, to figure out which layer or what sort of batch operation is taking more time. So still we can fine tune to have the best performance out of this ecosystem. And of course, we are scaling this to the cloud solution so that we can operate in a larger scale. So that is where we are today. So with the help of this migration, we were able to be in a better shape in the market for solutions. We were able to take the customer traffic more volume with the help of this migration. So thank you for this opportunity. We are open for questions.
Thank you so much, Team TransUnion. It's a great session. No questions, I guess. So, there's a question here in the back. Yeah. Sorry, guys. There's a question in the back.
Sure.
Mic, please. Is there a mic?
Thanks, guys. It was really a nice presentation. I just had one question on that batch thing. So maybe I missed it. So why are we using batch operations for read as well as write? I think there was a slide somewhere. Yeah.
Were you guys able to hear that?
Yep.
Yeah, I think this is batch operations to write the data to the database, to scale up our application to write billions of records. So we had two scenarios here, like in the adaptive map, one when a transaction exceeds the write block size. We cannot handle that in a batch operation. So that particular use case needs to be handled separately. So rest of the use case, we use batch operations. Like optimistically, we were trying to write the data to the root record. If it fails to record to be good, that is when we were taking a different route where we are pushing those transactions to a separate queue, and that will be handled separately as individual transaction. If if the operation was failed because of root record is already split, then we again use batch operations to evaluate what is the child record for which we have to update the data. And once we get to know the index of the child, we were using the batch operation to write to the right child record here. So it is just to scale our application to write the huge data which is incoming for us.
Hello. So initially in the beginning you said that there is a certain limit which Aerospikes enforce on the record size. But you still went ahead using Aerospike, and looks like some customization that you guys have done. So just wanted to know, why didn't you explore other options? What are the benefits? Not speaking against this conference or Aerospike, just wanted to know what are the benefits that you still observed and went ahead with this, even though you have to do, looks like a lot of customization. Thank you.
So, Ramesh, do you want to take this?
Got it. So let me quickly address that, right? So I think you're talking about the max write block size, right?
Yeah.
I think there are certain options, right? When the first thing probably Aerospike gives you a capacity sheet to fill in and all of that. So based on the nature of the data. In our case, it's not uniform for all the kind of identities, right? So we need to provide a solution for fraud prevention. And for each scenario, the data points may not be the same. For some scenarios, we'll have a rich amount of data points. For some scenarios, we'll have on an average. Okay? So the size that we chose was based on the average of our data sets, right? And similarly, you can go slightly larger, and if you look at those capacity sheets, there is a trade-off, right? You cannot have everything infinite in a way. So this is more a configuration based on our use cases, right? So when we say a limitation, it's more based on the amount of data, the data sets that we hosted in the Aerospike sets. So that 1 MB max, right, is based on characterization and analysis of our data sets, which we intended to put in Aerospike, right? That's the first part. Now, what are the other approaches if you look at it, right? Moving things to from a client side to server side obviously has various advantages. Now, on the server side, if you see, we did have a couple of options. One of these, and you also have UDFs, user-defined functions, and so forth to try out. When we tried out, we did not get the batch capabilities, one, and second thing, these are reads plus writes happening all through the day, I mean all the time, right? We cannot afford to be not recent, not have current data, and provide results to customers based on a day old data, right? So for these two specific reasons is when we why we chose to go with the adaptive mapless expressions. Anything else you may want to add more?
Sorry, just I think I don't know. There is a confusion. So this 1 MB limit was a self-imposed or something by Aerospike?
No, you can set it, right?
No,
the max write block size. Sorry.
Write block size it varies from I think 128 KB till 8 MB, and based on our data models, in our case, 90 to 95% of the data was we were able to accommodate in 1 MB write block size, and those 5% is the one which was exceeding that write block size, and we had to go with a custom implementation for that.
Okay.
Yeah, we can choose up to 8 MB for a write block size. I mean, that will have its own implication. So, in our case, the 1 MB was right suited for most of our requirement.
Got it.